In this video, we're going to talk about the order of operations because it's a lot bigger than you initially think it is. We have arithmetic and its order of operations, but beyond that, we have other things to worry about as well. For example, say I let x be 3, y be 7, and I go x less than 5 and y greater than 3. So how did that evaluate? It appears that x less than 5 is true, so 3 is less than 5. 7 is greater than 3, so both of them are true, and it evaluated the true. So the precedence here appears to be, and in fact is, that the relational operators have a higher order of precedence than the infix Boolean operators. So we've established one thing, that the Boolean operators have a fairly low order of precedence. It's lower than, less than, and greater than in all the other relational operators. Now, let's try this on for top size. 2 plus 2 is less than 5. Now, let's try this. Let's go ahead and do this just for fun. So I'm going to add a number to a Boolean. Result is 3. What happens is if you regard a Boolean as a number and the Boolean is true, that's a 1. If it's false, that's a 0. So we can see here that the plus bound these two together, stuck first before the less than. So arithmetic operators have a higher precedence than relational operators. Relational operators have a lower precedence, a higher precedence than the Boolean operators and an OR. Now when you do operations such as addition and multiplication like this, 2 times 3 plus 5, those operations associate from left to right. Now I'm about to show you an operator that associates from right to left, and that is assignment. Anytime you do an assignment. So if we go x is equal to 4 times x plus 5, we got 17. What happened? Well, Python evaluates this entire expression. Now, this associates from right to left. So it's going to go to the rightmost thing and start evaluating. And the precedence of assignment is really rock bottom lowest. Because what's going to happen is this is going to evaluate 4 times x plus 5. So multiplication first. We're going to get a 12. Addition next from left to right. 12 plus 5 is 17. And then finally, x gets 17 evaluates, and it has the side effect of setting x to be 17. This is true of all of the assignment and compound assignment operators. Let's play with a compound assignment operator. X times equals 1 plus 2. Okay, now, what happened here? Well, we go on here on the right. 1 plus 2 evaluates, we get 3. X times equals 3 triples whatever the value of x is. So 17 triples, and the result is 51. And voila, the result is 51. So in the order of operations, it's arithmetic operations, then are highest, and within those is the PEMDAS order you learned from Mrs. Wormwood. Then the relational operators come next. Then the Boolean operators come, and the dead last thing is assignment. Check this out, because if I go x equals, let's say x greater than 5 and x less than, less than 100. X is true. Because here's what happened. X is 51. It comes over here and evaluates that. 51 is bigger than 5. That is true. So we have a true there instead. Here we also have a true. Then we see true and true evaluating, which evaluates the true. And finally, that true gets assigned to x. X is now pointing at true. So you can see how the order of operations is working here. Now let's get down in the dirt with some things that are important. First of all, how about this? 4 plus minus 5. The minus is a unary prefix operator, and its order of precedence is high. So the minus bound to the 5, gave you a minus 5, and then it was added to 4, and you got -1. Let's do another little experiment here. 4 times. Actually, let's even square 4. And then let's multiply by -5 and see what happens. You got -80. Why? Exponentiation occurred first. So exponentiation is higher than the unary prefix operator minus. It did not associate the other way. So we can see that that has a fairly high order of precedence, the unary minus operator. Now, one other operator that you're going to see is the dot. The dot is the genitive case. So say I make a string. S is equal to, this is a string. All right. This is a string. Now, if I go something like this, S plus foo times 5, you can see the order of operations between the plus and the times are the same as the arithmetic order of operations. Now let's put a dot on here. Let's go S dot substring of 0 and 4, say, and then times 6. Oops. S dot, oh. String. Oh, that's right. I am, let's do this. I was operating in Java world for a moment. Let's go S square brackets. Oh, let's try square brackets on for size and see how that binds. 0:4 times 6. Who bound first? The square brackets operator binds before multiplication. So that binds very tightly. Now let's try this. S dot to upper times 5. Okay, S dot upper, not to upper. This is Python after all. Yes. And you can see the dot operator also has a very high order of precedence. So dot and square bracket, these are really behaviors of string objects. They bind before other operations do. They have the highest order of precedence. So this should give you a pretty good idea as to what the order of precedence is for operators in Python.